नोट्स बना लेना पहले, बाद में समझ लो पहले। देखो इसमें क्या एग्जैक्टली है, दिस चैप्टर इज एक्चुअली डिवाइडेड इनटू 3 पार्ट्स, है ना। तो इलेक्ट्रोकेमिस्ट्री का जो पार्ट आपने छोड़ा था गैल्वेनिक सेल, तो यू डिड इट।
या
गैल्वेनिक सेल के अलावा देयर वाज दिस पार्ट ऑफ इलेक्ट्रोलिसिस।
इलेक्ट्रोड पोटेंशियल किससे होता है?
गैल्वेनिक सेल में
तो भी तो
इलेक्ट्रोलिसिस का क्या मतलब है? इलेक्ट्रोलिसिस का मतलब है you are breaking down, right? The breakdown of a chemical. What is a chemical? Any electrolyte, right? Into its ions is what you call exactly any liquid. And which liquid? Any liquid which can give off its ions. Like for example, NaCl is a salt, but it can break down into its ions as Na plus and Cl negative. Any acid as in HCl. So it can give me H plus and Cl negative. Yes or no? Any base which would be NaOH would give me what? Would give me Na plus and OH negative. Yes or no? So NaOH, this is how these electrolytes are. So it is going to give me a cation on breaking down. Like Na plus is a cation, H plus is a cation. Here again Na plus is a cation. And it is going to give me an anion. And what is going to be my anion? The Cl negative is going to be my anion. Yes or no? So if this is going to be my cations and anions, so any liquid which can give me any ions, like 2 ions, every liquid has to give me. That is an electrolyte. So for example, if I'm talking about H2SO4, so H2SO4 gives me what? H plus and SO4 minus 2. If I am writing about how do I know the valencies of this? So this SO4, so this 2 is coming from the head of SO4 and no 1 here, nothing here, so 1 is there, so it is coming from the charge of H plus. So for example, if I'm writing down CaOH whole twice, you understand? So this 2 is coming from the head of calcium and OH minus 1. Generally, we write down the positive radicals for the first time. So at the first place, for example, we have Ca plus 2. So this Ca plus 2, this Ca plus 2 shall be written at the first position. Except for the fact, there is one more example. We have CH3, COOH. What is this? What is this? So it is going to be, how does it decompose? It decomposes like this. It breaks down like this. So CH3, COO negative and H positive. So only compound where you write down the negative radical first and positive radical later. 90% cases always NaCl, Na plus first, Cl minus later.
But
this is an exception, right? Just the way that when the bigger radicals are generally written first. And this is a anion. But anyway, this is a electrolyte. Why it is an electrolyte? Because electrolyte is somebody which can break down into its ions. Next is the electrolytic tank. Next terminology should be electrolytic tank. Now, what is happening in the electrolytic tank? Electrolytic tank is a tank in which you perform the process of electrolysis, right? And in electrolytic tank, we dip 2 rods. The 2 rods are called as electrodes. The 2 rods are called as electrodes. Yes or no? So we connect this to a battery. So this is the setup of a electrolytic cell, right? So these 2 yellow rods are called as my electrodes. What are electrodes? These are 2 conducting rods. These are 2 conducting rods which can conduct electricity. Which can conduct electricity. Now, depending upon the kind of rods we have 2 types of electrodes. We have passive electrode. We have passive electrode. And we have active electrodes.
Active and passive.
Right. Passive electrodes are those which can conduct electricity, you know, which can conduct electricity, but does not react with air or water or any chemical. Does not react with any chemical, air or water. You understand my point?
Hmm.
So that is passive electrode. So for example, when I'm talking about the passive electrode, what would that mean? Just tell me. When I'm talking about the passive electrode, like for example,
Conduct
platinum.
electricity, but they don't react with air
Yeah,
and water.
exactly. So platinum and graphite.
Yeah.
Only two examples of passive electrodes.
Means though conducting is passive.
है ना?
Yeah.
So electrons can flow in these rods.
Okay.
Electrons can flow in these rods, right? But electrons can only flow. Electrons cannot leave these rods. In a sense that, it is not something that this rod is of graphite, let's suppose, and it is giving electrons to the air molecules. It is not doing that. The electrons can move from one end of the rod to the other end and conduct electricity in the rod itself. That is what you understand with the term conducting, right? So that is the concept. Now understand. Then what do we understand by the active electrodes? Active electrodes are those electrodes which can conduct electricity, which can conduct electricity
And react also.
and react also. And react with the surroundings, with the surroundings. Right?
Hmm.
So this is the category of the electrodes that we have. What are electrodes? Electrodes are nothing but rods. ऐसी rods जो electricity conduct कर सकती हैं, जिसमें electron चल सकता है. So obviously there could be some metallic rods only, because only metals can conduct electricity.
Hmm.
So these are nothing but metallic rods. You understand? These are nothing but metallic rods.
Hmm.
Okay. Next, how do we sort of work with this now? Understand?
What is the example of passive? Platinum.
And graphite.
And इसका कोई भी iron.
Any metal, any metal. Apart from platinum, gold, all the metal rods are passive electrodes. Right? Active electrodes.
Apart from platinum and graphite.
And gold also. Gold doesn't react. And secondly, we generally use graphite. Reason being, graphite is cheaper, platinum is expensive. So we generally do not perform experiments with platinum rods. Next, what do we have in here? Next, what do we have in here? Understand? Now the point here is, in this example, right? Let's suppose I tell you, predict the products of electrolysis. These are NCRT questions, right? Predict the products of electrolysis of molten NaCl. Okay? Of molten NaCl in the presence of, it could be any electrode, right? In the presence of what? It could be graphite or platinum, one and the same thing. The work is the same for both of them. So either they write down platinum electrodes or they write down graphite electrodes. The method of solving the question remains the same because both of them belong to the category of passive electrodes. You understand? So what am I doing? I am taking this beaker. I am making the two rods. One rod I am connecting to the positive terminal of the battery. So this red one is a battery, the positive terminal, and this is the negative terminal. Understood?
The question is predicting
Products. So at cathode, what shall be formed? And at anode, what shall be formed? That is what we are supposed to tell.
will be in cathode and Ca minus will be on.
बताएं. So Na plus is there and Cl negative is here.
Yeah.
And now this rod is filled with lots and lots of electrons. Why so?
ये इलेक्ट्रॉन वहाँ ट्रांसफर हो रहा है।
हाँ, तो पढ़ा है ना ये चीज।
हाँ, ये पढ़ा है।
तो फिर और क्या छूट गया? अब तक वो पढ़ते समय याद आ रहा है। देखो, तो ये क्या है? Cl नेगेटिव है, तो Cl नेगेटिव इज गोइंग टू गो हियर. दिस इज विच रॉड? दिस इज विच रॉड? दिस इज प्लैटिनम रॉड और ग्रेफाइट रॉड.
Okay.
सही है. अब Cl नेगेटिव यहाँ जाके क्या कर रहा है? इलेक्ट्रॉन दे रहा है. फिर बैटरी ने क्या करना है? उस इलेक्ट्रॉन को उठाकर it has to transfer this electron from here to here. Only then this rod becomes negatively charged. So what is this? This is anode.
Yeah.
And Cl negative, when it goes and gives electrons here, so Cl negative is an anion. So anion transfers this electron to the rod and becomes neutral. And the battery pulls this electron and transfers to the other rod. So thereby this rod is becoming deficient of electrons. So this rod is positive. You understand? So positive rod attracts anions. Anions goes to a particular rod which is called as anode.
Okay.
So at anode, who is going? Cl negative is going. Right, Navya?
Yeah.
And Cl will become neutral by losing one electrons. So 2Cl negative will go to form 2Cl and 2 electrons. And 2Cl forms Cl2. You understand? So this is the product of electrolysis. That means chlorine gas is being displaced or discharged at anode. Now, what would be the product at cathode? Na plus will go here. So when Na plus goes here, so Na plus shall gain one electron. Because why it is gaining that extra electron? Because the battery is transferring that electron from here to here. So this electron has to be immediately transferred to somebody in the solution because the rod also wants to become neutral. So Na plus shall gain that one electron and it is going to form what? Na solid. So what is the product of electrolysis at cathode? Plus Na neutral. So this is the first level change. What is it called? Primary change. And what is the second level change? That is called as a secondary change. So here the two changes are taking place. So first time it is becoming just neutral. So this is my primary change.
Okay.
And second time it is becoming the from the atomic state it is converting into the molecular state. So this is becoming my secondary change. You understand? So this is the concept. So when we are talking about the products of electrolysis, so you have to tell me what is being produced at cathode, what is being produced at anode under the given conditions of electrodes. So in passive electrodes and molten salt we have taken. In the molten salt, nothing is there, only the salt. Only the salt is responsible.
यही होगा ना.
हाँ, उसमें different होता है. तो molten NaCl हो गया. So molten NaCl, the only electrolyte that I have is NaCl. Only NaCl is giving it of its own ions. So for example, I am getting the two ions Na plus and Cl negative. No other ion except the positive ions Na plus and except the negative anion Cl negative is present. So this is my Na. This is my basic electrolysis. So basically, I have broken down the salt into two parts and made individual parts as neutral components which have deposited themselves on the rod. Are you understanding?
Yeah.
Any doubts on this? Right? So this is the concept of cathode and anode.
Okay.
Now understand. So similarly, acha, one more thing. What would happen here? Okay, all right, now understand. Now this is another beaker. And if I take two more rods again, the rods are again made up of platinum. Platinum is a passive electrode. This is my battery. This is the negative terminal. This is the positive terminal. What would that mean? Now I have taken the solution of NaOH. So NaOH gives me what? Na plus and OH negative. It could be anything, right? It could have been a CaOH whole twice. So the anion shall remain OH negative and the cation shall become Ca plus 2. So I am taking for now only one electrolyte and that too in the molten form. So I have NaOH, molten. Molten means nothing I have added into NaOH, only NaOH is in the molten state.
Okay.
Now, when I have NaOH in the molten state, what am I getting here? So you break it down, Na plus and OH negative. So Na plus goes here and OH negative goes here. Are you understanding? What is going to happen? Just tell me. When Na plus goes on the other side and OH negative goes here on the other side, so OH negative goes because it says I am going to donate electrons to this rod. Because this rod is connected to the positive terminal of the battery, and since this electrode is attracting anions, this electrode is called as anode. So anode by charge becomes positive in the electrolytic cell. In the electrolytic cell, you understand?
बट ये से तो नेगेटिव होगा ना.
एनायन नेगेटिव होगा पर आपका जो एनोड है वो पॉजिटिव होगा क्योंकि बैटरी वहां से इलेक्ट्रॉन्स पुल कर रही है तो यहाँ पे इलेक्ट्रॉन्स रहने नहीं दे रही. So this rod is basically becoming deficient of electrons. So somebody has to come here and donate their electron to the rod in order for the rod to become neutral, and alongside the anion is also becoming neutral. So what is happening at anode? So at first we write down what is happening at anode. So one OH negative goes. So one OH negative becomes OH neutral by releasing one electron. But when it is a case of OH negative, you have to send 4 OH altogether. Always, always. Whenever you have to send OH, always send 4 OH together. So that you make 4 OH neutral, so that you have 4 electrons lost. And when you have 4 electrons being lost, so we have OH, 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 OH. These 4 OHs are becoming neutral. How do they rearrange themselves? See, H2O and H2O and O2. So we have H2O is formed and O2 shall be formed. So always, whenever it is a chance of OH negative to reach the anode, this shall always be the same product. So you can learn it as well. Then what is happening at cathode? Who is going at cathode?
Na.
Na. So Na plus goes there. And it is going to pick up which electron? The electron which OH negative has donated.
Yeah.
So 4 OH negative we have sent.
So 4 Na.
So 4 Na shall go because every OH is donating one electron. All those electrons are being transferred right here in the rod. So in one complete cycle, 4 OH donates individually one electron each. 4 electrons are transferred into the battery. It reaches the negative rod. Because it reaches the negative rod, this rod becomes negative. So Na plus gains 1 electron. I should send 4 Na because I have to make both the rods neutral in one cycle. So what is happening? So 4 Na plus gains 4 electrons, becomes 4 Na, solid. So what is the product here? So what is important that the electrons lost at anode should be equals to the electrons gained at cathode. And the product at here at cathode shall be sodium solid. Yes or no?
The non-solid, so it won't participate in the reaction.
No, it will deposit here on the rod. Or it will either settle down, whatever is the case, wherever it is settling down, but it is becoming now neutral. So it is no longer Na plus. When it is becoming neutral, it is not going to attract towards any of the rods.
The main goal is just to become
Neutral. Exactly. Exactly. What was this? This was molten electrodes. This was molten electrolyte along with the passive electrodes. This we have discussed, right? Now, let's suppose I take an example of CaBr2, calcium bromide.
Ca plus 2.
So now I don't think I need to draw the diagram for this. You know how it breaks down. It breaks down like Ca plus 2 and Br negative.
Yeah.
So this Ca plus 2 is my cation. And if you can imagine the diagram, this is going to be my anion.
Yeah.
Anion should be attracted towards the rod which is connected to the positive terminal of the battery.
Which is
Anode. Anode. So Br negative goes and donates electrons to this rod.
Yeah.
And Ca plus 2 goes here. Now, to make one calcium ion neutral, it needs basically 2 electrons. So 2 Br negative should actually reach, donate its own individual electrons. The battery shall transfer those 2 electrons into the battery, into the other rod. Exactly. So at anode, we will write down first. At anode, 2 Br minus gives me 2 Br neutral plus 2 electrons. And at cathode, what is going to happen? You tell me.
2 CFC, 2 CA
Not
plus
2 C. Only
CA2.
1 C.
अच्छा,
Only Ca plus 2.
CA plus 2,
Gains 2 electrons
so
to form
CA
Ca
and 2
solid.
electrons lost. So, okay, yeah. Okay.
Okay.
Yeah.
So the product here is, now this is not going to stop right here. This is the first level chain. This is going to be my primary chain. And this is going to be Br2. Because from the atomic form, the Br has what? 1, 2, 3, 4, 5, 6, 7.
Hmm.
Another Br will also have 1, 2, 3, 4, 5, 6, 7.
Hmm.
So what do you think we'll have it right here? Covalent bond will form. So the atomic form, this is my atomic neutral form of Br. And here it converts to the molecular form of Br. So when it is converting to the molecular form of Br, this is going to be my secondary change. Understood or not? Right?
Yeah.
So this is how we have anode and cathode thing.
Okay.
Now let's discuss about the aqueous electrolyte. The aqueous electrolyte. What do you mean by aqueous electrolyte? Aqueous electrolytes are those which have water dissolved in them. Are those electrolytes?
Which are?
Water dissolved in them.
Electrolyte. Electrolyte तो
NaCl
अच्छा okay
plus,
molecule mix H2O or
which have water
or solution based.
solution, which has water dissolved in it. Right? Like for example, NaCl notes नहीं बन रहे, वीडियो बन रही.
अच्छा okay.
So NaCl, basically if you heat it, like for example you take a pan and you put NaCl onto it and you heat it, what is going to happen? Tell me. Hmm.
It will break.
It will melt. But it is not going to melt very easily. It is going to melt at somewhere around 3000 degrees Celsius. That is why when you put salt on pan, you see nothing happening because the temperature of the pan that we use in our homes is not 3000 degrees Celsius. Yeah. So you need a lot of fuel to burn to convert this NaCl into the molten form. You understand? So we generally study, but how feasible it is in reality, that is very, very difficult to identify. Because NaCl, you understand, NaCl is a very strong, high melting point solid. So very, very difficult to, no, not the highest, but one of the highest. The NaCl, what do we have? NaCl is basically again very high. Yeah. So we can study that, okay, let us suppose we are successful in melting it down. Then we have two ions. Then Na goes to the cathode, takes one electron, becomes neutral, and Cl negative donates its two electrons, becomes neutral, and that's how it works out. But in reality, what do we generally end up preferring while performing electrolysis? Adding water, and then what water is doing, understand? See, what is water doing to this? Hmm. So when you add, this is the beaker, and this is Na plus, and this is Cl negative, and there is some force of attraction between Na plus and Cl negative, which is holding them together. You add water to it. So what is the structure of water? H2O. Exactly. And it has H is becoming positive and O is becoming negative.
H plus O.
So OH, exactly. So O is going to surround itself towards Na plus, O negative. So basically, O negative of the water molecule is going to twist and turn and align itself in such a way that the O negative is pointing towards Na plus. And here, what is it happening? O negative is pointing towards Na. Yes. So it is going to break down. So this is going to break down like this. We have this. What exactly is happening here? Just understand. So we have positive, we have positive, we have positive, positive, negative. And thereby, when these water molecules are aligning in such a way that all the H pluses and all the O negatives, they're going to pull the Na here, H pluses are going to pull the Cl here. So this bond is going to break. So even in the aqueous medium, the NaCl electrolyte is able to give off its ions. So there are ions of NaCl, but also some amount of water is also decomposing. So we have ions coming from both. Water is giving me H plus and OH negative, and NaCl shall give me Na plus and Cl negative. So both the electrolytes are donating their own electrons. So now in this example, we have two cations and two anions to choose from. You understand? Two cations and two anions to choose from. So this is the concept. So for example, when you have a beaker, and let's suppose I tell you, write down or predict the products of electrolysis of mole of aqueous NaCl in passive electrodes. In passive electrodes. What would that mean? See? So I will say that okay, the rods are same. The rods are the same.
It's not possible कि NaOH का एक charge हो ना कि NaOH कुछ HCl कुछ.
Now understand what is happening. So when we are saying predict the products of electrolysis of an aqueous NaCl in passive electrodes. So first of all, you predict the number of ions, total cations and total anions. So what do we have in here? NaCl we have. So NaCl forms Na plus and Cl negative. And water breaks down to form what? H plus and OH negative. So we have two anions and two cations to choose from. Now basically the one, so both of the cations can go towards cathode and both of the anions can go towards anode. But only one of them will go. And there has to be a preference that you have to make. And how do you make that preference? On the basis of the reactivity series. So ये पढ़ते हैं ना हम लोग काशीनाथ का माली आलू जरा फीके से पकाता है सीयू काशीनाथ का माली आली जरा फीके से पकाता है CUHGAGAUPT हाँ आलू जरा फीके से पकाता है हाँ so this is my reactivity series so in this reactivity series we can see Na plus and we can see H so the one which is at the lower end basically
Yeah.
goes towards the rod. Yeah. So out of Na plus and H plus, who do you think will go towards the electrode? So H plus shall go and gain the electrons. Always in the lower end of the reactivity series, the one that will go. Na will not. Reactive, it is going to lose electrons. Here it is going to gain electrons. So why will Na go to gain electrons? तो नहीं करेगा ना वो लूज करने जा ही नहीं रहा ना वो तो गेन करने जा रहा है और Cl नेगेटिव और OH नेगेटिव की अगर बात करते हैं तो यहाँ क्या हो रहा है Cl नेगेटिव और OH नेगेटिव में क्या हो रहा है यहाँ पे इसके रिएक्टिविटी सीरीज का ये ऑर्डर रहता है एनायंस की रिएक्टिविटी सीरीज ऑर्डर ये रहता है SO4 -2 NO3 -1 OH -1 Cl -1 एक मिनट ये बनेगा F -1 OH -1 Cl -1 Br -1 I -1 सॉरी Cl जो नीचे है वो जाए और वो जो अपना काम है वो करेगा तो बेसिकली यहाँ पे Cl जा रहा है और H जा रहा है तो Na जा ही नहीं रहा और OH नेगेटिव जा ही नहीं रहा so what is going to happen so this shall remain in the beaker and after electrolysis the solution that shall be left over will have the pH greater than 7 because obviously when this is getting discharged this is becoming neutral so solution will be basic हाँ तो आपको बस क्या लिख देना है इसके अंदर कि at anode और at cathode
Cathode is at left and anode is at right.
It's not necessary. I can connect the battery in the opposite end as well. Now this is becoming negative. Positive. वो इलेक्ट्रोकेमिकल सेल है वो डिफरेंस क्या होता है forms what Cl and 1 electron so 2Cl negative goes to form 2Cl and 2 electrons and thereby it forms what Cl
Yeah.
ठीक है
Cathode
कैथोड पे कौन भेज रहे हैं कैथोड पे हम H प्लस को भेज रहे हैं जो नीचे है
हाँ H plus
तो H प्लस जा रहा है तो क्या बन रहा है
H plus will gain electrons 2 electrons
so H plus 2H plus हाँ तो ये 2H बनकर 2 इलेक्ट्रॉन्स गेन कर
तो H2 जाएगा तो
ये H2
H2Cl2
हाँ तो दो अलग अलग प्रोडक्ट बने, तो यहाँ Cl2 बना, if let's suppose that we make the polarities proper. So if this is connected to the positive terminal, this is negative, so negative will attract H2 shall be released, and here Cl2 shall be released. Okay, so this is the concept of anode and cathode. Yes or no? तो इस तरह से आप प्रोडक्ट्स आइडेंटिफाई करते हो, isn't it? अब देखो, so if you, for example, if you have now AgNO3 aqueous using platinum electrodes, aqueous, हाँ, platinum, correct, एक मिनट, using platinum electrodes, अब क्या करेंगे? AgNO3, NO3 रेडिकल है, और aqueous है तो पानी, तो अभी we have two cations and two anions to choose from. So what is the reactivity series? काशीनाथ का माली आलू जरा फीके से पकाता है, CuHgAg. So Ag is here and H is here. So at cathode we are going to send, we'll write down the equations later on. So Ag plus. And at anode, who is going to go according to the reactivity series of anions? ये लिख लो आप reactivity series. Exactly. हाँ. तो F negative, OH negative, Cl negative, Br negative, I negative. So OH negative shall go. And OH negative, when we are sending, we have to send 4 OH negative because there is no choice. इसमें ही होता है, इसमें बाकी तो सबको पता ही है ना, Cl का भेजोगे तो Cl2 भेजोगे क्योंकि Cl2 बनाना है, 2H2O बनाना है, exactly. So it is going to form what? OH, OH, OH and OH. So it is going to form what? H2O and H2O, and it is going to form 2H2O and O2. So this shall be formed right here. Yes or no? And at cathode it is going to form one electron. So it is going to form Ag solid. Simple. Any doubts on this? Questions asked. यही आते हैं प्रिडिक्ट करने के लिए, प्रिडिक्ट हमारा ये Ag और H2 O2 बना, यहाँ पे O2, हाँ वाटर तो चला गया पर O2 बना यहाँ पे, क्योंकि वाटर तो फिर से उसको aqueous बना देगा ना, तो ये बन गया, और क्या बीकर में रह गया? You are left with H plus and NO3. So after electrolysis the beaker's pH becomes less than 7 and नहीं, ये बनाएगा HNO3, नाइट्रिक एसिड, करेक्ट. समझ आ गया? तो बस ये प्रोडक्ट्स हैं इसके अंदर. अब इसमें इसका जो क्वालिटेटिव पार्ट है, जो इसका क्वालिटेटिव जो क्वांटिटेटिव पार्ट है वो देख लो. तो क्वांटिटेटिव पार्ट में क्या हो रहा है? क्वांटिटेटिव पार्ट में आपसे पूछेगा कि भाई इफ 5 amperes current is passed through molten NaCl. छोड़ ये पकड़ लो. ये हो जाएगा, ठीक है, ये वाला हो जाएगा, ये वाला हो जाएगा, ये वाला हो जाएगा, ये भी करा, ये वाला हो जाएगा, ये वाला हो जाएगा, ठीक है, ये वाले सारे क्वेश्चन यहाँ पे, यहाँ पे ये हो जाएगा, ये वाला हो जाएगा, ये वाला हो जाएगा. प्रोडक्ट्स ऑफ इलेक्ट्रोलिसिस यही बता देते हैं. अब देखो इसके अंदर क्या सीन है. So how does NaCl breaks down? Na positive and Cl negative. So Na plus is going to do what? Na plus is going to gain one electron and becomes Na solid. If I read this particular equation, how do you read this? That ma'am, 1 mole of Na plus ions gains 1 mole electron to give me 1 mole Na solid. Yes or no? So when 1 mole of Na plus ions are going to gain 1 mole electrons, so what is the charge of one electron? 1.602 into 10 raised to power minus 19 coulombs. So charge of वन वो राउंड ऑफ कर लो, आप कर सकते हो, आप वो राउंडिंग ऑफ है लेकिन एग्जैक्ट वैल्यू यही है. So charge of 1 mole electron shall be what? 1.602 into 10 raised to minus 19 into 1 mole's value is 6.022 into 10 raised to 23. When you multiply this, you get it's a number of particles like dozen. 96478 coulomb, approximately rounded off to 96500 coulomb. You understand? So when you have 96500 coulomb, this is the charge of 1 mole electrons, and you call this value as 1 Faraday. 1 Faraday is a bigger unit of charge, and bigger unit of charge as in charge of 1 mole. Huh. 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 Exactly. So when I ask you, so formalize this. W is equals to molar mass of anything that you want to check into molar mass upon I NF into IT.
NF is Faraday.
What is N? The charge of the Na.
Yeah.
What is F? 96500.
Okay.
What is molar mass? Na's molar mass is 23. What is I? I is current. And what is T? 2 hours. Hours have to be converted into second. So 2 into 3600 seconds. 7200. 1 hour has 3600 seconds. And therefore, if you calculate, you get W. You understand? Mass, which is getting deposited. So now, up till now, we have been discussing there are no Na gets deposited here.
Okay.
So if Na gets deposited here, what is going to happen? Tell me. If Na gets deposited here, some mass of Na must have been depositing, right? It's not always 23 grams that shall be depositing. This is the standard equation. हर बार इतना ही deposit हो, that's not necessary. It could be 1 gram deposition or 2 grams deposition. Whatever is that deposition is W. So that W we are calculating by this formula. So for example, here if you do MnO4 minus 1 and let's suppose it is converting into Mn plus 2. हाँ, aqueous में हो रहा है. Let us suppose if I say calculate the Faradays required.
Basically F.
हाँ, कितने Faraday चाहिए?
तो
मतलब
mass is given over the beginning.
हाँ, Faraday की वैल्यू आप निकाल नहीं सकते, वो फिक्स है.
हाँ.
क्योंकि उसका मतलब है 1 मोल इलेक्ट्रॉन्स का चार्ज. अभी बताती हूँ, एक मिनट. तो अगर मैंने बोला 5 मोल इलेक्ट्रॉन्स चाहिए, तो 5 Faraday हो गया ना सीधा सीधा. 6 मोल इलेक्ट्रॉन चाहिए, तो 6 Faraday हो गया ना सीधा सीधा. ये बोल रही हूँ. तो अब अगर आप इसको सॉल्व करोगे तो माय क्वेश्चन टू यू इज दैट इन दिस पर्टिकुलर कन्वर्जन, और ये एनसीईआरटी का क्वेश्चन है, देख लेना इसको, मेरे को नहीं पता कौन से नंबर का, बट एनसीईआरटी है, तो फिगर इट आउट. तो कहता है कैलकुलेट द Faradays रिक्वायर्ड टू डू व्हाट? रिक्वायर्ड टू कन्वर्ट 1 मोल ऑफ MnO4 नेगेटिव टू Mn plus 2. तो अब इसमें Mn का चार्ज कितना है पता नहीं, तो Mn का चार्ज है 1 का x, तो एक ऑक्सीजन का चार्ज कितना है -2, तो 4 का कितना है -8 इक्वल्स टू -1, तो x shall be -1 plus 8, so x shall be what? +7, and from +7 it is going to +2, so it is going to do what? It is going to gain 5 electrons. तो 1 mole के लिए 5 mole electron gain करना जरूरी है, only then it is going to convert into Mn plus 2. So how do you read the equation? That 1 mole of permanganate ions gains, or requires 5 mole electrons to form 1 mole of Mn plus 2 ions. So there were, yeah, the coefficient right here means the moles. 1 mole. So 5 mole electrons means what? 5, it is going to give me 1 mole of Mn plus 2. So 5 Faraday charge. And in coulombs, what would that be? 965. Exact. 5 into 96500 coulomb. That is the net charge.
And then अगर मास निकालना तो एम आई टी फाइनल
हाँ, अगर वो देता है कि भाई आपने 5 एम्पियर करंट लिया for 60 minutes, for 60 seconds, let's suppose, for 1 minute it's just. And then calculate what mass would be deposited. In that scenario, you will be needing the mass of manganese, which is I think somewhere around 58 or 60. तो उसके हिसाब से W निकालो आप. तो MIT over NF. So अब यहाँ पे N क्या है? यहाँ पे N चार्ज नहीं है. यहाँ पे N है कितने इलेक्ट्रॉन्स ले रहा है वो to become this particular part. तो 5 है.
ओके
तो असली में नॉर्मली हम क्या लिखते हैं? Ag प्लस विल गेन 1 इलेक्ट्रॉन्स टू फॉर्म Ag सॉलिड. तो एक्चुअली एक ही ले रहा है to become neutral, तो हम N को 1 ही लिख देते हैं. बट इन रियलिटी इज द चेंज इन द चार्ज. तो मोलर मास डालो 58.5 जो भी है मैंगनीज का. आई है आपका कितना? 5 एम्पियर.
सपोज अगर हमारा -1 नहीं होता यहाँ पे -9 होता
कहाँ पे?
यहाँ पे -1 तो आपका जो एक्स की वैल्यू है वो -9 आती है वो पॉसिबल है.
मैंगनीज का बेटा तो डीएफ पढ़ के आई है. मैंगनीज +7 से ऊपर कहाँ जाता है?
हाँ बट अगर मैंगनीज कुछ
-9 प्लस पहली बात तो मेटल है. मेटल कांट शो नेगेटिव चार्जेस.
हाँ तो प्लस ही रहेगा.
वो प्लस ही रहेगा. हाँ ठीक है, इतना समझ आ गया. तो ये बात है, इस तरह से आप फॉर्मूला लगाओ. हाँ इतना समझ आ गया. सब में ये अब जैसे मान लीजिए आपको बोल रखा है कि भाई एम इज मोलर मास.
निकालना पड़ेगा. नहीं एम इज
वो दिया होगा, वो याद होना चाहिए कुछ कुछ का, और आपको कुछ कुछ का पता होना चाहिए. दैट्स फाइन. तो Cr+3. अब क्या करें? तो 1 मोल अगर ये आयन है और उसको Cr+3 में कन्वर्ट होना है, तो आपसे पूछ रहा है हाउ मेनी फैराडेज यू वुड बी रिक्वायरिंग. एक का x तो 2 का 2x क्रोमियम का. -14 shall be -2. So 2x shall be -2 plus 14. So 2x shall be 12. So x shall be 6. एक क्रोमियम का +6 है, एक क्रोमियम का, पर इस पूरे मॉलिक्यूल में 2 क्रोमियम है ना, तो 2 का +12 हुआ. अब एक का यहाँ +3 हो रहा है तो 2 का प्लस, क्योंकि अगर ये टूटता है x क्या अज्यूम किया था आपने? एक क्रोमियम का चार्ज. कि जब ये क्रोमियम टूटेगा तो मुझे ये 2 क्रोमियम देगा और 7 ऑक्सीजन देगा. ये देगा ना. और फिर ये कन्वर्ट होके 2 Cr+ बना रहा है. तो माय पॉइंट टू यू इज कि भाई जब ये दोनों कन्वर्ट होके इधर 2 Cr अलग हो गए, तो पूरे मॉलिक्यूल के अंदर जो 2 Cr थे, एक ने +6 से +3 ट्रांजिशन दिखाया, तो एक ने 3 इलेक्ट्रॉन्स गेन करे ना, तो दूसरा भी तो 3 इलेक्ट्रॉन्स गेन कर रहा है, तो ओवरऑल मॉलिक्यूल तो 6 इलेक्ट्रॉन्स गेन कर रहा है.
तो एक्चुअली बाद में जो कर दिए साथ में किया.
हाँ, तो अरे नहीं, पर निकालते समय तो चार्ज निकालते समय तो 2x करोगे. कैसे करोगे? नहीं तो अगर आप 0 रख रहे हो या -2 यहाँ चार्ज रख रहे हो, तो व्हाट इज योर इंटेंशन बिहाइंड दैट? कि क्रोमियम का चार्ज और ऑक्सीजन का चार्ज जो भी है इसके ऊपर, दैट इज एडिंग अप टू -2. दैट्स माय क्वेश्चन.
So we could have left it till 2x equals 12. Because
कर सकते थे, कर सकते थे, कर सकते थे, कर सकते थे. मतलब अपनी अगर एक बार समझ आ जाएगी तो उसके बाद कर सकते थे. बट ये मेरे को सिखाना ऐसे था कि एक का इतना था तो इसका था. बाकी अगर अंडरस्टैंडिंग होगी तो कर सकते हैं, कोई इतना इशू नहीं. ठीक है, इतना समझ आ गया. तो लेकिन मॉलिक्यूल में जो इलेक्ट्रॉन्स जा रहे हैं वो तो पूरे मॉलिक्यूल में जा रहे हैं ना, और पूरे मॉलिक्यूल में 2 क्रोमियम है, तो हर क्रोमियम 3 इलेक्ट्रॉन्स ले रहा है और Cr+3 में कन्वर्ट हो रहा है. तो ये पूरा मॉलिक्यूल इफेक्टिवली कितने इलेक्ट्रॉन्स गेन कर रहा है? 6 इलेक्ट्रॉन्स गेन कर रहा है ना.
यहाँ पे 12 थे, यहाँ पे 6 था, तो 6 चाहिए.
हाँ, तो 6 फैराडे नेट चार्ज लग गया. किसके लिए? इसके 1 मोल के कन्वर्जन के लिए.
यहाँ पे +3 है ना, +6 है तो 2 क्रोमियम.
2 क्रोमियम. 6 फैराडे चार्ज कितना हो गया? 6 × 965 00 कूलम. सिंपल. ठीक है, अब आगे चलो. अगर फॉर एग्जांपल मान लीजिए मेरे पास है क्या, मेरे पास है Ni NO3 होल ट्वाइस। और मुझे क्वेश्चन कहता है कि आई हैव पास्ड 6 amperes of current for 1.5 hours. Calculate the amount of nickel deposited. तो कैसे करोगे?
Na plus 1 with
Ni मतलब ये 2 आ रहा है,
Na plus Na plus Ni 2 plus है,
तो ये Ni plus 2 है,
gain 2 electrons to form Ni solid.
Ni solid. अब फॉर्मूला लगा दो, वेट निकालना है जो निकल डिपॉजिट हो रहा है, MIT ओवर NF, N क्या है चार्ज, तो मोलर मास निकल का जो भी होता है देख लेंगे अभी टेबल में कितना होता है एग्जैक्ट नहीं, 50 नहीं होता, 56 होता है। निकल का देख,
ये तो इंडेक्स ये रहा निकल टेबल कट
ये लॉग टेबल
लॉग
58.6 होता है, वही मैं कहती हूँ 58.6। आई कितना होता है, आई निकालना है अपने को 6 एम्पियर दे रखा है, टाइम है 1.5 आवर्स इंटू 60 इंटू 60, और नंबर एन क्या है, नंबर ऑफ इलेक्ट्रॉन्स 2, और फैराडे कितने हैं 96500। तो वेट आ जाए, सारी वैल्यूज डाल दी, ठीक है, जो भी है। तो मास आई टी, टाइम को मिनट्स में कन्वर्ट करा इंटू 60 सेकंड्स में करा, ओवर एन क्या है 2 और एफ क्या है 96500। समझ आ गई बात, तो ये कॉन्सेप्ट है, तो ये डब्ल्यू आ जाएगा, कोई दिक्कत, ठीक है। तो इस तरह से आपने इसके क्वेश्चंस करने, एन इज द चार्ज, ठीक है। अब नेक्स्ट इसके अंदर क्या हो रहा है, नेक्स्ट इसके अंदर एक क्वेश्चन आता है कि H2O है जैसे, और H2O से O2 बन रहा है, तो कितना फैराडे चाहिए टू प्रोड्यूस 0.2 moles of O2 from the electrolysis of water. पढ़ो, 0.2 moles O2 बनाना है, so for the production of 0.2 moles of O2 ये बनाना है, how much charge you would be requiring. Now balance the equation. So what do you need? 2 times ये करेंगे तभी O2 बन रहा है, सही है। तो हम क्या पढ़ते हैं जब वाटर की इलेक्ट्रोलिसिस कराते हैं, तो व्हाट डू वी राइट इट डाउन, वी राइट इट डाउन दैट इट ब्रेक्स इनटू H plus and OH negative. So 4 OH negative gives me 4 OH neutral and exactly and 4 electrons. This further neutralizes itself to H2O and O2. So basically to produce 1 mole of O2 I need 4 Faraday charge according to this particular equation. So 4 Faraday converts to 1 mole O2.
तो डिवाइड करेंगे 0.2,
करेक्ट, तो अपने को 1 मोल 1 मोल O2 के लिए 4 फैराडे चाहिए, सो 0.2 मोल O2 के लिए हमें क्या चाहिए 4 इंटू 0.2, क्या निकालना है फैराडे निकालना है, 1 मोल के लिए 4 फैराडे चाहिए, तो 0.2 मोल के लिए कितना चाहिए, तो 0.8 फैराडे चाहिए फॉर द डिपोजिशन ऑफ 0.2 मोल O2. So 0.8 Faraday shall become 0.8 into 96500 cool. Yes or no?
Yeah.
Any doubts in this? So that is the concept, right? So for the production of 2 moles of H2O, we have this concept.
ये वीडियो भेजते हैं,
शेयर कर दूंगा, ठीक है। और देख लो, अब क्वेश्चन जैसे कई बार ये बोल देता है, ये पढ़ो क्वेश्चन खोलो, एनसीईआरटी खोलो, लास्ट पेज खोलो, ये क्वेश्चन कह रहा है 3 इलेक्ट्रोलाइट्स हैं ए बी सी, एक बीकर है उसमें ZnSO4 डाल दिया है, उस बीकर का नाम दे दिया ए, दूसरा बीकर है, उसका नाम रख दिया बी, उसमें AgNO3 डाल दिया, और C है COSO4।
और कनेक्टेड इन सीरीज
सीरीज में क्या सेम रहता है? करंट। तो सीरीज में अगर
of 1.5
करेक्ट,
was passed through them until 1.5
ग्राम्स ऑफ सिल्वर डिपॉजिट। तो यहाँ पे जो Ag डिपॉजिट हुआ वो 1.5 ग्राम्स डिपॉजिट हो गया, 1.45।
How long did the current flow? What mass of copper and zinc were deposited?
करेक्ट। अब सिल्वर का मास होता है 108 मोलर मास। तो जो करंट इसमें गया 1.5 एम्पियर वही इसमें गया, और वही इसमें गया। और अगर आपने बैटरी ऑन रखी है फॉर एग्जांपल 16 मिनट्स के लिए, तो सब में 16 मिनट्स के लिए गया। अब मुझे टाइम नहीं पता, लेकिन पर मुझे इसने क्या कर रखा है, एक बीकर का बता दिया कि 1.45 Ag डिपॉजिट हुआ है। तो फॉर्मूला सेकंड बीकर के लिए लगा दें, W is equals to MIT over NF। तो what weight is getting deposited? 1.45 is getting deposited. What is the mass? 108। करंट जा रहा है 1.5, टाइम अपने को पता नहीं। N क्या है सिल्वर के लिए? Ag प्लस विल कन्वर्ट टू, विल गेन 1 इलेक्ट्रॉन, एग्जैक्टली। तो ये हो जाएगा, तो ये हो जाएगा 1, और F कितना है? 96500। तो यहाँ से मुझे क्या मिलेगा सॉल्व करके? T। और इतने ही समय के लिए करंट इसमें भी पास कर रहा है, इसमें भी पास कर रहा है, और इसमें पास कर रहा है। तो इससे मुझे क्या समझ आता है? T मिल जाएगा। अब इसके लिए जिंक निकालना है कि जिंक कितना डिपॉजिट हुआ बैटरी पे जाके या रॉड पे जाके। तो जिंक प्लस 2 गेन्स व्हाट? 2 इलेक्ट्रॉन्स टू फॉर्म जिंक सॉलिड। अब यहाँ पे हो क्या रहा है मुझे बताओ, कि अगर वो जिंक सॉलिड गेन कर रहा है, दैट मीन्स इट इज गोइंग टू गेन 2 फैराडे चार्ज, है ना। तो आपका N हो गया 2, तो इसके लिए फिर से W निकालेंगे, तो मोलर मास होता है 63.5 जिंक का, I है 1.5 करंट, टाइम जो भी यहाँ से आएगा, तो वो टाइम यू विल सब्स्टिट्यूट राइट हियर, ओवर N क्या है 2, और F क्या है 96500। सॉल्व कर दो, आंसर आ जाएगा। तो ये किसका वजन आ जाएगा, किसका वेट आ जाएगा? जिंक डिपोजिशन आ जाएगा। ऐसे कॉपर का निकाल, कॉपर के लिए भी इट इज गोइंग टू बिकम Cu प्लस 2 इलेक्ट्रॉन्स टू फॉर्म Cu सॉलिड। So all I need to know is N for copper.
CuSO4 होता है ना, SO4 तो माइनस 1 है,
SO4 प्लस 2 माइनस 2 होता है, ठीक है। तो कॉपर सॉलिड बन गया, बस क्या दिक्कत है इसमें। तो प्रोडिक्ट करने आने चाहिए, प्रोडक्ट उनका मास निकालना चाहिए। अब सारे क्वेश्चंस कर पाओगे इसके, जितने भी क्वेश्चंस ये वाले दे रखे हैं। अब यहाँ पे क्वेश्चंस क्या दे रखे हैं इन्होंने, देखो यहाँ पे बोल रहे हैं 20 ग्राम्स ऑफ कैल्शियम को कन्वर्ट करना है, बनाना है CaCl2 से। तो 20 ग्राम्स कैल्शियम मतलब हो गया गिवन मास बाय मोलर मास कर लो, तो 0.5 मोल्स कैल्शियम बनाना है बेसिकली। जो भी मास है उसको मोल्स में कन्वर्ट कर लो, तो गिवन मास है मोलर मास। तो बेसिकली आपको पता है CaCl2 जब टूटेगा, so it is going to give me Ca plus 2 and 2 Cl negative. So Ca plus 2 shall do what? Shall gain 2 electrons to become Ca solid 1 mole. So I will say that to deposit 1 mole, 2 Faraday is required. So I should write it down this way. So basically to deposit 1 mole of calcium, I require 2 Faraday charge. So thereby, because equation gives me the values of moles. वही तो बता रही हूँ, equation basically deals with the number of moles. The question is in terms of mass. So I can convert that mass into moles, isn't it? So 20 over 40 shall give me this moles, isn't it? हाँ, तो आपको 0.5 moles आधा कर दिया ना इसका, तो 0.5 moles of calcium के लिए I would be requiring 1 Faraday, and 1 Faraday is how much? 96500 coulomb. समझे? So this is one concept. Then have a look at the other part.
40 grams of aluminum for 100
So aluminium's molar mass is 27.
तो molar mass
Given mass by molar mass will give me moles. So 40 grams over 27 grams shall give me the number of moles.
फिर हम वो फॉर्मूला लिखेंगे, Al plus 3 O minus. So Al plus 3 requires 3 electrons to attain
Al solid. So basically what is happening? So to deposit 1 mole,
it requires 3 Faraday.
So to deposit 1 mole, it requires 3 Faraday charge. So to deposit, how much is that? 40 over 27. So let's multiply this 40 over 27 because 1 mole. So you will get 40 over 9 Faraday.
अच्छा तो ऐसे भी कर सकते हो, so work out.
Obviously, when you know the value of 1 mole, how would you convert this to the same value? So yeah, but basic unitary method comes from 7th 8th grade. वो आना चाहिए. जो भी आएगा 4.44 4 9 for 36 9 हाँ इतना फैराडे है. ठीक है, तो बस इस तरीके से आपको सॉल्व कर लो. क्या दिक्कत है इसके अंदर? अब जैसे ये वाला क्वेश्चन है 5 एम्पियर दे दिया, टाइम दे दिया, मिनट्स है. हाँ, अब इसके अंदर क्या करोगे, बस निकालना है कितना निकल डिपॉजिट होगा. निकल का चार्ज +2 है, हो जाएगा. ये वाला कर लेगी. यहाँ पे कितना फैराडे लग रहा है, 2 फैराडे, यहाँ 3 फैराडे. 1 मोल के लिए चाहिए. किसी और मोल के लिए भी पूछ लेगा तो क्या करेगी, 1 मोल के लिए इतना चाहिए तो 5 मोल के लिए कितना चाहिए, इंटू कर देगी. सेम क्वेश्चन
हो जाएगा -1 नहीं
mn का चार्ज निकालो ना. यहाँ पे कितना है, +5 निकाला था ना. हाउ डू यू कैलकुलेट द चार्ज ऑफ MnO फॉर. हाँ,
5 फैराडे चार्ज चाहिए.
एग्जैक्टली. अब यहाँ पे क्या है, अब यहाँ पे ये वाला क्वेश्चन देखो, सेम क्वेश्चन.
ये तो करा.
इसमें पूछ रहा है कितने कितने फैराडे चाहिए. तो क्वांटिटी ऑफ इलेक्ट्रिसिटी बेसिकली मींस इट इज नाउ आस्किंग यू द चार्ज, क्वांटिटी ऑफ इलेक्ट्रिसिटी इन कूलम. So if you require few Faradays into 96500, that much coolant. That's it. इसमें क्या दिक्कत है, सारे क्वेश्चंस कर पाओगे. अब जैसे बोल रहा है if the current of 0.5 amperes flows through the metallic wire for 2 hours, how many electrons would flow through the wire. ये तो करो, अभी तो फिजिक्स का क्वेश्चन है, करो.